Hi to all. Today I am going to explain the telescopes. What is a telescope and what is the use of the telescope and how many types of telescopes are there, and about one type of telescope I am going to explain. Now actually what is telescope? Okay, let us start. Telescope is a device. Telescope is a device used to see the distant objects. Distant objects means the objects which are far away from us. We can see that objects by using the telescope. A device used to see the distant objects. Okay, distant object may be stellar objects. We can see the planets, or the distant objects which may be present on the surface of the earth. Then anything that we can see, right? Anything which is at the long distance from us, that we can see by using a device that is called as telescope. A device used to see the distant objects is called as telescope. Telescopes are two types. Okay, these are two types. What are they? These are two types. The first one is refracting telescope. Okay, first one is what? Refracting telescope, and the second one is reflecting telescope. Two types of telescopes are there. The first one is the refracting telescope. Refracting telescope. These refracting telescopes are again classified into two types: astronomical telescope and terrestrial telescope. This astronomical telescope is used to see the stellar objects. Okay, this is used to see the stellar objects, and this is another one is a terrestrial telescope. This is used to see the objects which are present on the Earth's surface. And the second type of telescopes are the reflecting telescope. In the reflecting telescope we use the mirrors. In the refracting telescope we use the lenses. Okay, these are two types. In this, first I am going to explain about the astronomical refracting telescope. Okay, right? I am going to start the one type of telescope, that is refracting. In our syllabus we have the astronomical refracting telescope and reflecting telescope also we have. And first I am going to explain the astronomical refracting telescope, right? Astronomical, right? Refracting telescope. What is the use of this telescope? This telescope is used to see the stellar objects. Okay, it is used to, a telescope used to see the stellar objects. Okay, this is a device or the telescope used to see the stellar objects. Okay, stellar objects means what? We can use the planets, we can use to see the planets, stars. We can see by using this device. This is called as astronomical, means we can see the astronomical objects. That's why it is called as the astronomical telescope. Astronomical objects these are at long distance from us. Okay, that we can watch by using this astronomical telescope. And now, what is the construction of astronomical telescope? What it consists? Astronomical telescope consists two convex lenses, right? You listen it here. Astronomical telescope consists astronomical refracting telescope. Astronomical telescope consists of two convex lenses. Okay, now this astronomical telescope, what is the use of this astronomical telescope? You see here, The astronomical telescope consists of two convex lenses. One is called as objective and other one is called as the eyepiece. It has the two lenses. That is, the one lens is called as the objective lens, and other one is called as the eyepiece. Okay, it has the two convex lenses. Their names are objective and eyepiece. And in order to get the large magnification, okay, to get large magnification, the focal length of the objective must be greater than the focal length of the eyepiece. If focal length of objective is greater than the focal length of the eyepiece, FO we can consider as the focal length of objective. I will write like this. You can write in sentence form. That is, we have to select the two lenses in such a way that the focal length of objective is focal length of objective lens. Focal length of the objective lens is greater than focal length of the eyepiece. Focal length of eyepiece. Why like this? Okay, and then the focal length of the objective greater than focal length of the eyepiece, if it is followed, then we get large magnification. In order to get the large magnification, then we will use like this. And one more point is that aperture of objective is also greater than the aperture of eyepiece. Aperture of objective lens is also greater than aperture of eyepiece. Aperture means what? Diameter of the lens. Okay, the aperture, the area through which the light passes, right? If aperture is more, the area is more, diameter is more. The aperture of objective is greater than the aperture of eyepiece. There is A naught greater than AE. If like it is obeyed, then if aperture of objective is greater than the aperture of eyepiece, then the resolving power is more. Okay, resolving power. Resolving power means every part will appear clearly. Okay, resolving power is more. Okay, and what type of image it forms? What type of image it will forms? It forms virtual. We cannot catch, but we can see inverted is a reverse image, and magnified image forms. Magnified image forms. Okay, now you take the screenshot and note it. Then I will continue. I will derive the magnifying power of astronomical telescope formula. Okay, I am going to rub it. Now let us see here magnifying power of astronomical telescope that I am going to derive. Magnifying power means I am going to derive the magnifying power of astronomical telescope angular magnification formula. What is angular magnification and how the image forms by the lens or this astronomical telescope that I am going to explain. Astronomical telescope consists of two lenses. This is the objective. You see this is the objective, and this is the eyepiece. You see here, objective has the large focal length. Objective focal length is FO, and aperture is also more, the size is also more. This is the eyepiece, and now this is the line passing through the optical centers of the two lenses is called as the principal axis. This is the principal axis. The optical center of the objective we can consider as O. Optical center of the eyepiece I will consider as O dash. And now let us take the image is at far distance from the infinite. The light rays, when the object is at long distance, then its image forms at the focus. When object is at infinite distance, then image forms at the focus. Let us consider there is only one objective lens. Okay, there is one objective lens, and object is at infinite distance. From the infinite distance, the light ray starts, and then they will meet. The light ray which is passes through optical center, it cannot deviate. It can go in the straight, and the light ray which is incidenting it here, it will bend, and they will meet at a point, and here the image will be forms. This image we can consider as the AB. And what is the location of this image? If object is at infinite distance, for the objective lens, object is at infinite distance, right? Then the image forms at the focus. Image forms at the focus of objective. Okay, when object is at infinite distance, then the image is at the focal length. Then according to that, let us draw the diagram for this. One light ray I am taking, that is coming from the object which is at infinite distance. Okay, that is passes through optical center. It can go in the straight. And another light ray I am taking like this, it is incidenting. And these two light rays are parallelly incidenting. That means they are coming from the infinite distance. And after the refraction, they will meet at a point. And where they will meet, there the image will be forms. And really the light rays are meeting, that's why the real image will be forms at here. And this is the real image, right? The image we can take as the AB, and the image height I will take as H. Okay. And now this image is at what location, right? This image forms at the principal focus of objective. Why? Because object is at infinite distance. That means for the objective lens, object distance is infinite. U suffix O. For the U means object distance, O means objective. For the objective, object is at infinite distance. Which is objective? Star or sun or any planet. They are at very far away from us. That's why we can say that they are at infinite distance. From the infinite distance, light rays parallelly incidents. When light rays are incident parallelly, after the refraction, okay, this convex lens forms the infinite object image at the focus. At its focus, then this point is the focus. This is FO. It is at what distance from the objective? Right. This is at FO distance. FO is what? FO is the focal length. Right? FO is the focal length. Now, what is this? This is the image distance. Image distance for what? Objective lens. That is equal to F0. For the objective lens, object is at infinite distance, U0 is infinite. Image is at the focus, image distance is F0. And the image forms by the objective lens will act as object for the eyepiece. This is the image forms by the objective lens. This image acts as object for the eyepiece. Then this eyepiece forms the image of this object. Then where is the image? The image of this object, the location of the image of this object, okay, formed by this eyepiece, depends upon the position of the object. Then let us consider this position is adjusted by moving the lenses, and then we have to make in such a way that first let us consider the objective eyepiece focus is at here. This is considered as the FE. This location I will consider as the FE. Okay, this location I will consider as the FE. Let us see here. This is the FE. FE means it is the principal focus of eyepiece. Right? This is the FE. Capital FE means principal focus of eyepiece. Principal focus means it is a point. Okay. And now the object is in between the principal focus of eyepiece and optical center. This is the eyepiece principal focus. This is optical center. In between this object is there. Okay. This is actually image forms by the objective. This act as object for the eyepiece. Now it is object, and now this eyepiece forms the image where it will forms, right? And it is in between the principal focus and optical center. That's why image forms on the same side, right? That is the virtual image and enlarged image that we know already, right? And now, for example, for the eyepiece, we can take the object distance as this is the object distance. but for this is the object distance for the eyepiece, that's where u suffix e. Now where it will forms the image, for that we have to draw the ray diagram. One ray we will take that is passes through optical center, it can go in the straight without any deviation, right? And another light ray I will take that is incident parallelly, and then after the refraction it will passes through focus. For example, this is the focus of eyepiece. Okay, and now let us draw the diagram. And now this is the focus of the eyepiece, this point. Okay, right, this is the parallelly, this light ray is incidenting parallel to the principal axis, then after the refraction passes through focus of eyepiece, right? And now on the right side the distance between the two light rays is increasing, that means they never meet on the right side, but there is a chance that these two light rays are appears to be coming from a point on the left side. Then we can do the extension on the left side, then go back like this. Right, like this we can do the extension. These two light rays are appears to be coming from a point, and there the image will be forms. This is the final image. This is the final image. The final image is IG. Final image is IG. Look here, this is the virtual image, and it is enlarged image and inverted image. Object is above the principal axis, image is below the principal axis. Now image distance is what? You see the picture. The image distance for the eyepiece is VE. Okay, right, whatever it may be the VE. If the image forms at the near point, if it is near point, okay, if it is near point, okay, it is at what distance? 25 centimeters. Then we can take VE as D. Okay, this is the image diagram when the image forms at the near point. Okay, and now let us go for the derivation. For the eyepiece, object distance is UE and image distance is VE. And now we know magnification formula, right? What is the formula for the magnifying power? Magnifying power formula is, there is one formula that is previously we discussed, right? Oh, that is different. Now we discussed some other, here I will explain some other formula, that is angle made by image. This is angular magnification we are finding. Angle made by image, we can take it as beta by angle made by object. Angle made by object. Okay, now look at here, this is an object, this is an object. Okay, here object is there, from that light ray starts an incident, and the object light ray is this one, and this is making some angle with the principal axis, that we can take as angle made by the object. It is alpha. According to the mathematics, this is also alpha, and this is the final image. This image is making some angle, right, with the principal axis. This angle, this is the image light ray, right? And now the image is making some angle that we can take as beta, right? Okay, now the magnifying power formula is beta by alpha. We can write, when beta alpha are small, then we write a tan beta by tan alpha also we write. Okay, this m is equal to beta by alpha. From that we can write it as tan beta by tan alpha. When beta and alpha are small, we can write like that. Okay, when theta is this, we can write like this. If theta is small, okay, if theta is small, we can write theta nearly equal to tan theta, just like a 0 is equal to tan 0. Tan 0 value is 0, right, like that. And now let us continue. Now here we are going to derive the magnifying power formula, right? And for that, here you see the diagram In the diagram, I am going to write the formula for the tan beta and tan alpha. Okay, let us see here what we will get. And here tan beta is what? From what triangle we will get the tan beta? Let you see the triangle you take, that is O dash A B is a triangle you take. Okay, from that you write the tan beta. Okay. Triangle O dash A B, tan beta we write. What do we write the tan beta from that? Tan beta is equal to opposite side by adjacent side we write. That is AB by, okay, you see here, this is the triangle O dash AB. Tan beta, this is beta. Beta is equal to AB by AO dash we write. AB is H I am considering. Okay. And AO dash is UE. Okay. Right. Next, tan alpha I want. I will take the triangle OAB triangle. You write the tan alpha formula right here. Okay, you see here OAB. Tan alpha equal to opposite side again. That is opposite side is AB again. Alpha opposite side. This is alpha. This is alpha. You see here. This is alpha. Okay. This is alpha. I will write clearly. Right, that is alpha. Alpha opposite side is AB, by adjacent side is OA. And now this we write as H by OA value is F naught. This you substitute in that equation, then we will get M is equal to tan beta by tan alpha. Tan beta by tan alpha. Tan beta is H by UE by tan alpha is H by F naught, and H gets cancelled, then we will get F naught by UE. And magnification formula we got is F naught by UE. This is considered as equation 1. And now what we have to do it here, right? In case of eyepiece, what is the object distance? For the eyepiece, object is what? AB is object. Object distance is left side. Object is left side, right? For the eyepiece, that's why minus UE. And image also forms on the left side. That is minus E. V is equal to image distance. We can consider as minus VE. And the focal length of the convex lens we take as the positive. That the focal length we can take as the plus FE. Now substitute all the values in this. Okay. Right, let us go for the thin lens formula. 1 by F is equal to 1 by V minus 1 by U. From this you substitute all the values at here. F is FE and V is minus 1 by VE minus 1 by UE is minus UE. Now if you simplify this, we will get 1 by FE is equal to minus 1 by VE plus 1 by UE we will get. Now 1 by UE we will get as 1 by VE plus 1 by FE we will get, and this is equation 2. Now what we have to do it here, the equation 2 is substituted in equation 1. Equation 2 is substituted in equation 1. If you substitute in that, then what you will get? You see here, equation 1 is F naught by UE. This we write as F naught into 1 by UE. F naught into 1 by UE. But the 1 by UE is this one. That is 1 by VE plus 1 by FE. Right, you see here. And here we can common the FE at here. FE we can common. And then we will get like this. F naught by FE is equal to F naught by FE into FE by VE plus 1 we will get. And this we can write as like this. That is M is equal to F naught by FE into 1 plus FE by VE we write. Okay, FE by VE. And this is the important equation, and this is the formula for the magnifying power of astronomical telescope when final image forms at a distance VE. Okay, look at here. F0 is the focal length of the objective and FE is the focal length of the eyepiece, and that is the formula for the magnifying power of astronomical telescope. Take the screenshot and note it. If you have any doubt, you can ask me. Okay, I am going to rub and I will continue. Two cases I will take. One case is that that if object image is forms at the near point. If image forms at the near point, then we will take the image distance is equal to capital D. In this we substitute the VEI is capital D. Then we will get the magnifying power formula when final image forms at the near point. Then that is F0 by FE into 1 plus FE by D we will get. And one more formula is that one more is I am going to derive the formula when final image forms at the infinite distance. When the final image forms at the infinite distance, then we write here final image distance as infinite. Here you substitute the image distance as infinite. Then 1 plus FE by infinite. If something by infinite is 0, then finally we will get the F0 by FE, right? And now here we can also write the length of the telescope. Okay, you see here, this is the equation 3 here we got. If you want the length of the telescope, what is the length of the telescope? Okay, length of the telescope is nothing but the distance between the two lenses. From the figure, what is the distance between the two lenses? F0 plus UE, right? Okay, now we will discuss the special cases based on this. Okay, you take the screenshot and note it. Let us see the special case, that is when final image forms at the near point and when final image forms at the infinite distance, then what are the formulas and how they will be, that we will discuss. Let us see here first, that is before that, magnifying power, what you got in the previous equation, right? What you got from the previous equation? There is a magnifying power we got as magnifying power formula, previous equation we got as M is equal to F0 by FE into 1 plus FE by VE. This is the formula that you got from the previous equation. And the length of the astronomical telescope I want. Length of astronomical telescope. What is the length? Length is nothing but distance between the two lenses. You see the figure and tell what is the distance between the two lenses. That is the distance between the two lenses is F0 plus UE from the figure, right? F0 plus UE. Okay, what is UE in this? Object distance for eyepiece, right? For eyepiece. Now let us go for this we are considering previously equation 3. Now this we can consider as equation 4. Okay, and equation 3 we are writing again at here. Okay, you see here from equation 3 and 4. Now what we do here we have to write we have to take the cases. The first case is that when final image forms at the near point. Okay, if final image forms at near point, then what is the formula for the magnifying power? Final image forms at near point. What is the near point? Nearest point at which object is seen clearly, at least distance it will forms. That means, okay, if final image forms at near point, then we write image distance is equal to, then image distance is equal to least distance of distinct vision. This is called as LDDV, least distance of distinct vision. Okay, this is substitute. Then from equation 3 and 4, what you will get? The same thing you will get. Okay, from equation 3 we will get the magnifying power formula, that is F naught by Fe into 1 plus Fe by Ve become D. Okay, right. And now this we can take as equation 5. And what about the length of the compound microscope? Telescope. The length of the telescope is same. There is no change in the F naught and UE. We write F naught plus UE. Okay, right. This is equation 6. And these are the formulas when final image forms at the near point, right? And if the final image forms at the near point, then what is the diagram? Diagram is already in the beginning we drawn the same diagram we have to use. And the next case is that if a final image forms at the infinite distance, then what is the case? Let us see the case 2. This is important. You see here case 2, that is if a final image forms at infinite. Okay, we have to understand this one. When final image forms at infinite, if a final image forms at infinite, that means final image distance should be infinite. Actually, generally we know for certain convex lens, if object is at the focus, then image forms at the infinite. That means in order to form the image at infinite, the object distance should be equal to focal length, right? And then the diagram, how it will be there. Let us see. We draw the diagram for the object telescope when final image forms at the infinite. You see this. This is the objective, and the next one is the eyepiece. This is the objective. Its focal length is F naught, and this is the eyepiece. Its focal length is F suffix E. Okay. Now the optical center of the objective is O. Optical center of the eyepiece is O dash. Let us see, the object is at infinite distance. From the infinite distance, the light ray starts parallelly. And let us take the one light ray that is passes through optical center. It will go in the straight and without any deviation. Let us take another light ray that is parallel to this one. Why these two light rays parallelly incidenting? Because we are taking the object at infinite distance. This astronomical telescope is used to see the stellar objects. Stellar objects are almost at far distance. We can take them, their object distance as infinite, and then they will be refracted here, this light ray, and it will meet at one point. It should be straight, not like this. Now this light ray will go in the straight like this. Okay, no bending, and this will bend and meet the second light ray at here, and here the image will be forms. Okay, you see here the image will be forms. This is the image forms by the objective lens, and now this image will act as object for the second lens. The second lens forms the image of this one, and then where the image will be forms at here, the image distance is equal to focal length, because it will forms at the focus of objective. For example, it is also the focus of eyepiece. If it is the focus of the eyepiece, then where the image will be forms. To know the image, then we have to take again the two light rays, right? One light ray I will take that is passes through optical center, right? Then it can go in the straight like this, and one more light ray I am taking that parallelly incidenting. Okay, and this will goes after the refraction. It will passes through focus. It will go like this. Now these two, this is also focus of the eyepiece. When you see the right side, okay, then they are going parallel to each other. The distance between them is constant. Then they, on the right side, they will go to up to infinite distance. Then the infinite image will be forms. Okay, this object distance is what at here? Fe. Why it is Fe? Because the image, original object is at what distance? Infinite distance. The image is at the focus of objective lens, and if this image acts as object for the eyepiece, final image should be formed at infinite. Then for that, this object, okay, this is the object for the eyepiece. This object should be at the principal focus of eyepiece. If it is at the principal focus of eyepiece, its length should be equal to focal length. Then the image will be goes up to infinite distance here. Then we have to, okay, this is the ray diagram when final image forms at the infinite. And now let us see here, what is the object distance at here? What is the image distance for the eyepiece? That you see here, these two light rays right side, they are going up to infinite distance because they are going parallel to each other. The distance between them is constant. Distance between them remains constant. If the distance between them is constant, then the image forms at the infinite distance. Image forms at the infinite distance. Then at that moment, magnifying power is what? Here we have to take the conditions that object distance for the eyepiece, okay, object distance for the eyepiece, it is equal to Fe. Then image distance for the eyepiece is infinite. Then these conditions substituted in equation, these conditions substituted in equation 3 and equation 4, then what you will get? The m, right, from equation 3, that we will get as F0 by Fe into 1 plus Fe by Ve is what? Infinite. Final image forms at the infinite distance. Then something by infinite is 0, 1 plus 0 is 1, 1 into F0 by Fe is F0 by Fe. We are getting the final formula as F0 by Fe. F0 by Fe. It is the final formula for the magnifying power when final image forms at the infinite. What is the length of the telescope? Okay, length of telescope, right? What is the length of the telescope? How we will get the length? Length is nothing but distance between the two lenses. What is the distance between the two lenses? This is F0, this is Fe. Length of the telescope from the figure we will get as F0 plus Fe. Okay, you see here, this is F0, this is Fe. Then we will get F0 plus Fe. This is equation 8. You see equation 4, F0 plus Ue. But here this is the Ue, object distance for the eyepiece. This Ue is only equal to Fe at here. Okay, here V0 is equal to F0. Okay, here U0 is equal to infinite. Here Ve is equal to infinite distance, like this. Okay, this is the formulas. Thank you for watching my lectures. If you have any doubt, you can ask me. Till now, if you not subscribe my channel, subscribe and share to your friends.